All right, so principle number 4. Here's the question. We talk about the interfaces, we talk about abstract classes. I assume everyone have a good understanding about the differences between the two. Now the question is, well, both of them give you this kind of a capability to form a hierarchy and to build this kind of inheritance type of relationship. Is there a preference when we are trying to write a code? Does anyone have some opinions about this? So if there's a problem that you can solve, or not a problem, if you want to have build a structure with the inheritance, do you prefer to go with interface or abstract class? Yeah, Catherine, can you comment more? Give me a couple of criteria you use. What is the situation you probably will consider interface, and what situation you will prefer abstract class?
So I guess if the subclasses have fundamental differences, you should go with interface. If not, I guess you should go with abstract classes.
Sorry, you said the what class is not fundamental? Could you repeat the first half? Sorry.
I'm thinking if the subclasses have fundamental differences in their behavior, it's better to go with interfaces. But if the subclasses are some kind of similar and share most methods, go with abstract classes.
Very good. That's actually a really important point we want to bring today. Okay, so I think you're talking about that in a different way, but that actually shows a really nice feature about interface. Now remember when we talk about interface, it's very flexible because you can have multiple interfaces on the same class. And you can apply any kind of interfaces. I give you this example. You can do something like unrelated or not directly related type of interface also to the class. So that kind of flexibility will be one thing you should consider, because sometimes your class might not fall into a nice abstract class type of hierarchy if you just force them to be together in the same parent class, subclass by inheriting, by reusing some of the code from parent. It may work for your code purpose, but it's a very bad or wrong hierarchy. All right, so that's absolutely something you should consider. All right, so this question is really not as simple as a private public, where we just told you can just go with private. Obviously, this one for sure it has different kind of scenario you need to think about. Now, to understand this question more, I just want to show and highlight again some of these special pros and cons about each method. Then you will decide what to use. All right. So this one's here, let's go through some of these bullets. All right. And the interface, again, it's really flexible. It allows any kind of a class to be adapted. So again, especially if you think of this kind of a simple interface like comparable. I don't know how many of you have done this interface. With a data type, you create your own class. Or let's say student, let's say like a PC game or Mac PC game, all of those. And it's your own customized data. By default, you cannot really compare greater or less or equal, right? However, you can always implement this comparable interface, and then you implement something called a compare to method. And then you do some logic here, you specify your logic, your way to compare different things. Then you can apply this interface anywhere you want. No matter whether you have hierarchy or not, you can always add this extra interface called comparable to your existing class. So this one gives you the most flexible way to apply something. All right. So that's something really convenient about interface, because again, the reason is in Java, you can apply as many interfaces as you want, and it doesn't really matter how many. All right. However, when you are doing the abstract class, you're limited. You can only have one abstract class in your hierarchy, in your class, as your parent class. If you are already one, then you cannot have another one. Right? So this one is less flexible compared with interface, but also it actually implies some other situation that in certain situation it just doesn't work, very well, or it will mess up your hierarchy. Take a look at this one. If you want two classes to extend the same abstract class, you have to put the abstract class high up in the ancestor of both classes. Can anyone understand this one? All right, thinking about you have two hierarchies. All right, so let me see if I can use this annotation. Okay, so you got some class here. All right, and then this one has a parent class. Now you got another class here, and this one also has a parent class. And this one has another parent class. Okay, you got a two hierarchy. They're totally separated. However, for some reason you find, oh, I want this class A to extend a abstract class as to reuse some of the feature. And then you can definitely extend it from here, because you cannot do two inheritance. You have to do one. So you basically will extend this one here. Okay, I'll call this one as R to reuse. And then later on, you'll find out that, oh, this B also want to extend that parent class for some reason, to reuse the code or whatever. Again, you cannot directly go from B to here, because you cannot extend more than one hierarchy, parent class. So you have to go all the way to the up to the ancestor, and then from there, you build a inheritance relationship. This is what I mean here. If you want two classes to extend the same abstract class, you have to go all the way to the top. Once you have this, you start to realize that you are actually creating a new family here. And somehow these things all become related. All right. And that might not just make sense at all. However, from the extension point of view, I mean, if you want to extending a parent class, this is the only way to go in Java, because you require to only have one parent class. Okay, that's what I mean here. Okay, so I give you maybe a little bit more concrete example. Let's come back, see if I can create something. Let me open some example we did before. Probably use this kind of PC game example. All right, so let's see here. I have a PC game. All right, I have a Mac PC game. I have a Windows PC game, right? So that's one hierarchy. Now I'm going to create another one. I will create a maybe book. All right, for book, I have some different kind of book. I have a paper book. This one already extends the book. And then I have a digital book. Extends the book. All right, two hierarchy. Okay, book and then game. They're not related. They're all product, but they're really not related. At one point, I found there is a class, for example, something called download link, not download link, like a download generator, URL generator. Let's say that sometime if you want people to download your product and something, then you can use this one to generate some kind of a code. For example, you got a public string generate random URL. For example, there's a method like this. It does very sophisticated logic that allows you to get a URL very easily. So you find, oh, this is a very good method to reuse. All right. And I want to extend this class because, for example, the digital book, I need this one. but I cannot really put it here directly because I'm already part of the book. So I actually have to go all the way up to say extend download URL generator. That way, inside this digital book, I can start to call this one, right? For example, I would do a test. So probably avoid the test. I can call, generate random URL because that one come from parent and parent. Okay. And also on the other hand, let's say that the Mac PC game. All right. So a lot of this, let's assume that here I also want to generate some links. Then again, you can't put it here. I have to put it all the way to PC game. And this one here, I will extend download generator. All right. By doing this, somehow your PC game and the book, all of this become together in one family. They're called download URL generator. However, if you look closely in your family members, obviously not everyone applies, okay? Your regular paper book doesn't apply to this one. And also, even if you believe that they somehow still related, when you put this one all the way up to the high position, because this is the top level, and then every member in the whole family tree, in the whole hierarchy, have this access to this method. They can all use this one, all right? And you might be thinking, what's the problem? Then is it better because now everyone can reuse this method? So again, thinking about the rule about information hiding, you do not want developer to see the things they're not supposed to see, because the more they see, the more likely they will use that one. Also, they will have the extra burden to understand, what is that? Do I need to use that or not? And how do I use that? And so that's why it's a very bad practice when you put all the way up to the high hierarchy as a parent class just for the reuse purpose, because you cannot really put it directly here, right? So that's one really downside about this abstract class. It's not flexible. It's one parent only, and you have to put it all the way up. There's another one here, really important. Extending an abstract class may cause conflicts with existing method. All right, so this one is actually more dangerous. So back here, same example, okay, download digital like a URL generator. All right, so let's say that I have, so when you are extending an abstract class, okay, abstract class may have a lot of methods. In this case, you got a digital book. You're trying to call this method from, from the top level. But then sometime you will see that there will be a method with the same name, and then somehow it actually override it. So let me do this example, guys. How about this? So let's say this generate a random URL. It actually calls something as for example, I'll do this one, okay? Get unique ID, okay? So this one will just return you a unique ID using some kind of random method, okay? And then let's say that this method here actually need to get this ID, and then we put this ID as a part of the random URL, right? So that's very reasonable. So I got this structure here. So there we use a get unique ID, right? However, when you are working with some of your games, you also need some special ID. So in a PC game, let's assume you actually also have a method like this, public string, exactly the same. But then you're just using a different algorithm. Maybe for the game, you actually need to use some kind of game, some kind of ID, right? But this method was built there for the PC game already. But you're just adding this one later on. Now you see what's happening is when you're trying to call Mac PC game, when you're trying to call, let's say, get some of the, when you're trying to call this again. If I try to call generate URL, now this one is going to call this method, This method is going to call get unique ID. However, at this point, it's not going to call this one right here. It will call the overridden version, which is PC game right here. Right. So this is called a conflicts. Because you have no knowledge about what this new parent you're extending, what they have, but you have something here, and then just accidentally, this one has exactly the same name as this one, so it's going to override that method when the subclasses are calling. That's going to change the behavior of this one here. All right, so that's another potential issue about inheriting a abstract class or just a regular class. So from this example, you should see that when you are extending a class just like this, all right, for sure, it's really nice because you extend something, you immediately reuse everything from that parent class except the private stuff. Public, protected, you can reuse that one. It provides a lot of efficiency for your coding. You reuse a component, you don't have to rewrite everything. It's all nice. However, at the same time, you should know there are potential risks that some of the methods might conflict with the ones you have currently. You should be very, very careful on those. All right. And also, if you have two classes that you need to kind of inherit the same thing, you really want to be careful because do they really belong to the same family? Okay, most of the time it's not. But then if you have in interface, then you won't need to worry about this issue. All right, so that's what these slides are talking about. Let me see some of the questions here. Yeah, Arush, I agree. So this method probably makes more sense as a static public utility method, but I'm just making up the example, right? So obviously this one, you shouldn't actually make like inheritance. It makes more sense to make a utility method, all right? But this is just an example. There will be a situation that some of the class do have a lot of some of the good methods that you can use, but then it's not really appropriate to make as static. But here I'm just trying to show you an example. All right. So here I just want you to understand the good, the bad, some of the risky parts. All right. Okay, so keep going. This one also here, let's actually talk about, oh, this is more about the same thing we talked before about the interfaces. When the interface, you can have this kind of a mixing the type, same thing we talked about before, like some of this interface that has nothing, or have very simple like a method for you to do. It's just a kind of a like a type, and you can really apply the type to any of the classes you want. It doesn't matter whether they're related or not, and it's super flexible. All right, so that's just another one benefits of using this interface. But then you cannot really do the kind of type thing with abstract class. It's very heavy, and then you will inheriting a lot of different things. All right. So these are pretty much this one and this one are talking about the same thing. Sorry, let me go back. Interfaces are super simple, flexible, where abstract class are heavier because it has a code there, and then you can only do that once a time in the same hierarchy. So it's less flexible. You want to be careful about using that. All right. And here's another example. Like sometimes you have the thing that doesn't fall into a hierarchy, and the interface will give you a kind of solution, right? So for example, here you got a singer, you can sing. You also have a songwriter, you can compose a song. All right. So these are two different kind of roles. All right. However, you do have sometimes a certain somebody that can do both writing a song and singing, right? There are a lot of those people. And if you want to describe that kind of a concept, you can easily just merge them, create another interface, right? Called singer-songwriter. And then that new class can just inherit this interface and just do something with it, right? Otherwise, if you do think about if you build this thing, there's a class, and then you build another class that inherit one another one by one. So eventually you kind of merge them, you force them to be in the same hierarchy. And that's just not very reasonable. all right? But all of this, you know, it sounds like a big principle. However, it all comes down to this capability of interface being able to do multiple interface where the class, you only have one choice. All right. However, I also want to mention some of the things you should be cautious about interface. So this one is not really a simple yes or no question. All right. Abstract class absolutely also has its you know, advantages because you can reuse code. Where interface, it simplify the type, the hierarchy, but then you don't get any kind of concrete code from it. All right. Something else you need to know is it is a lot easier to involve and change an abstract class rather than a interface. All right, because once the interface is released and implemented, it's almost impossible to change. All right, so that's something I told you last time. Interface, because everything is public. When they're public, when they're being used, and that is a contract. All right, because when only people can call and apply the public message. So you create one interface. You might not feel it's a big deal, or you know that you only use this interface for twice in your project, in the current project. However, you never know one day how many other people are actually implementing and reusing your interface as well. You just didn't even know it. All right, but that happens very, very commonly, especially in the big companies. Inside a big company, most time people have their own internal, like a GitHub type of thing. They don't use GitHub; they use their own like a code hosting. You can search for all of the code. You can look at all the examples and most of the code, unless it's like a secret project, and you can feel free to add a dependency and reuse somebody else's code, because a lot of things have been done there in the company. You don't have to, you know, recreate everything by yourself. A lot of that you just don't know and don't realize that people are actually using your stuff. Obviously, only public ones. Otherwise, they can't reuse unless they change your code. So at that time, you are actually serving a contract. Okay, if one day you decide you change the name, you change the number of input parameters, you change the return type, that's going to be a disaster, because the moment you push your code and then the moment that they synchronize the latest version of the library, they find out their code all broken, totally broken. All right, so that's why you should be very cautious about the interface. Once you release it, it's pretty much, there's no way you can change it. That's why sometimes in Java, you might see some of the methods called deprecated, right? They're not recommending to use. However, you can still use it. There's nothing wrong with it. It's just not a recommended way for you to use again. You might wonder, why don't they just delete it? They can't. They can't. Because some of the Java interfaces and classes it's been there for 20, 30 years. And if Java decide to change and delete the one method, that's going to break the whole world. Okay, I think that will be the consequence. So they might be able to add a new method and then deprecate the old one, but they cannot really change the old one, even though they may realize that it's not a very good design. All right. However, for the abstract class, it's a lot easier because there's so many things you can do internally. Obviously, if it's the public, then you still cannot do it. But if it's some other behavior, then you can change the interface. Sorry, internal design and logic. You can change the private method, the protected method. That's a lot easier. Okay, I won't say you won't have issues, but it's just a little bit easier than interface. All right. So these are the things you really need to keep in mind about interface. It's a more about responsibility, even though it's a flexible. All right. Yeah. So this is the point I was trying to tell you, that inside the organization, your code is often reused, or for you know, at any point you cannot assume that this is only for yourself to use, right? Unless this is just your personal project. Okay. All right, so design the public things very carefully, design the interface very carefully, and don't try to change it. All right, so but in general, I think you can tell what we recommend is use interface. It's more flexible. It gave you a better way to build your structure. That's why that one is always preferred. However, this is not a yes or no question. There might be cases that you still need abstract class. All right, any questions? Okay, so 2 more rules. Number 5, do we prefer class hierarchies or tag classes? Now, this is the easy question, all right? So the class hierarchies means that you're building a hierarchy with inheritance, where the tag classes, I will show you an example, you will know what I'm talking about. It's basically based on types. So this is a class hierarchy. Very classical example. Abstract class, parent class called figure, and then you got this method called get the area. And then you got 2 different shapes, circle, rectangle, they're both type of figure. And then for circle, you need to specify the radius. You have a constructor to receive radius, and then you have a method implementation to calculate the area using the circle formula. For rectangle, you need a width and height, and then this is how you receive the 2 parameters, and you implement the same method called get area, and then that's how you calculate the area for rectangle. So very standard hierarchy, different subclass types, same parent class, and that's how you build the hierarchy. Very nice. That's the way we recommend you to do. That's called object-oriented programming. However, there are still kind of old-fashioned way to build the same thing, which is called tag classes, or tag classes, same thing. So this is one type of implementation. We don't want to use hierarchy. I just merge everything together. All right. But I can do that with circle, with rectangle, or something else. I just use another attribute here to specify my type. I use a enumeration type here just to specify a type, or I don't have to go this one. I can specify integer 0, 1, 2, 3 to specify what the time I'm looking for. And I create all the attributes to save the possible attribute I might need. And I created 2 method to constructor to receive those. You can have your choice to choose which one to use. And then when you calculate the area, then you have the switch statement that if depending on the type, I'm going to choose a different formula. All right. So this class also pretty popular at one point because you got a one thing for all purposes, and then you can still choose what you want to do and automatically set up the type based on the constructor you're calling. And then when you call this area method to calculate the area, you can still, again, get the correct answer because they will know the type. They will use the same formula. All right. However, when you compare this one with this one, you start to realize that this hierarchy is so much more readable, but more importantly, it's much more extensible. It's easier to change. Again, back to this point about the design, how do we judge if it's a good design or not? It's all about the changes. If you are trying to add something, for this one, all you need to do is add another class, extending this figure, implementing the area, that's it. Where for this one, you add a type here, attributes, constructor, and you add one more case statement here to specify a new type. Again, same point. So you will realize that the amount of code you're adding between the 2 examples are almost the same because you also need to do an attribute method here where you just spread them across the same class. You don't really see an increased amount of code. However, don't think about this one just with this simple example. Think bigger, because in reality, the amount of code you're adding to some of this part will be more than you saw, so that when you try to, for example, delete something, all right, that's one trouble. Now you need to go back to delete this one here, all of this one, it's gone. You have to delete it manually. But here you just need to get rid of that class. Another example, another thing that you can't really tell from this example is, what if I want to add another method? For example, right now I want to have a get area, right? I want to add something called get volume, for example, get volume, right? And then for here, I just add one method and then implement all of this. But for here, and then also I need to basically create another place where I check all the types and do the same thing. So really the problem about this tag class is if you decide to use the tag, all right, And you have to use that tagging logic, checking the type always. And that's a very, very bad practice. Because what if I need to change the type later on? Okay, think about in your class, you have so many different switch statements to check the type to do so many different things. One day I told you, okay, we do not have circle anymore. Please get rid of that. Now you need to go back to check all of this switch statement and delete that line. Where for this one, all you need to do is delete that one class. All right, so this is a much cleaner structure for you to manage the changes. There's no exception. This one is always bad for changes. Again, if the code remains the same, that's all right. That's all right. Not a really big deal. But you know, when you need to change, all of this one is going to give you a huge amount of trouble. All right. Not to mention some other things like you keep some of the unreused attribute. This is obviously very bad. But then the major issue is all of this checking the type. Very bad idea. Right. So for the hierarchy, simple, clear, and there's no relevant data, obviously everything is good. So there's really nothing to talk about. And so some of the lessons I want you to know is, number one, if you want, since you know the hierarchies are good, now we should try to build as many hierarchy as we can for your project, for your example. All right. So this one we'll talk a little bit more in the future. A lot of the time when you write something, okay, I'll give you an example. Let's think about an example. Let's say that today, all right, we are you're writing an algorithm, you're writing a little application. So I will write another package here. All right, so I will do like for example, let's do like a downloader. Okay, maybe we'll write something called like a let's do this. Let's do a YouTube downloader. Right? Some of you probably have used that one. I use that very often to get some of the videos for different purposes. You can just download those from the YouTube, right? So YouTube downloader. All right. It sounds like a very practical like algorithms. Assume that you know how to, for example, find the video link and then use some of the URL, sorry, the HTTP library to download the stream and save it into the file. It shouldn't be a very difficult thing to do. And I think you can probably figure it out. Now, if you're writing that program, I think that this is probably the way most of you will go, right? So you probably will do something like, okay, public void, you know, download YouTube. All right, so you provide a URL, and then you will just do something with it, right? And then when you start to use, you will do something like this. All right, and then you start to call that. Okay, YouTube downloader. Right, and then you say download. Something like this. All right, and then you wrote a lot of code right here to implement the logic, right? Yeah, so you might think, you know, I'm just writing an algorithm. It's very clear. I know the step to do, step 1, 2, 3. How do I get the URL and then download stream, save the file? Why do I need to worry about a hierarchy or whatever whatsoever? Okay, so I can tell you, if this is given a professional Java developer, okay, believe it or not, they're not gonna write this one first, okay? Even though they know what they need to do, they need to write that logic algorithm to download the URL, but they will create an interface right away, okay? So before they write this class, they actually will create something called, you know, video downloader. And then they will actually write something called public void, you know, download video. They will always start with that one, and then they write this one to, you know, implement it. Video downloader. iVideo, sorry. Right, and then you know, implement the method. All right, since they use this method here, so let's actually use this name here. I'm going to change the name. All right, so let's not use this one here. Oh, actually, I need a URL. So they need to put a URL here. So let's do this again. All right, so they will actually implement this logic here to the class. All right, so you will call something a download video. All right. Okay, that's how the professional will do. Then you might think, yeah, so what, right? So you add an interface, I understand. I know how interface works. I know you add a method, and then this one here is good, all of those, you know, but it doesn't matter because you still need to do all this logic. I don't really think that's a big deal, right? So that's generally how a junior developer will see this kind of a situation. But they don't realize that how easily things can be changed, okay? One day you suddenly realize, oh, you know, our product needs to be extended. I want to support not only YouTube downloader, but also I want to support some other YouTube website. I don't know what other video site you guys are looking for, right? So there are some other things. Again, I don't know. So maybe, for example, CNN, right, also has the videos. I'll do a CNN video downloader, all right? And then you will start to implement the same interface and iVideo, all right? And then you do your logic here, right? So now you as you can see, eventually, whenever you want to change, this one becomes a very easy change. And then when you start to apply all of this, it becomes so simple, all right? So because all of these different algorithms, or maybe somebody else wrote another algorithm, they call it like fast YouTube video downloader. And then that implement the same interface, all right? Different algorithm, faster, but lower quality, right? So you got so many different implementations, eventually you can easily switch and change whatever you want without any other part of the code to be changed. So what I'm telling you right now, guys, is anytime you cannot really say that my software doesn't change. For professionals, okay, for example, for me, when I see this thing, the moment I'm writing this algorithm, I can start to foresee so many possible changes later on, because this algorithm is not going to be the one version you will have. So that kind of mindset is not something most of our students will have, because you don't realize, oh, actually, we will actually change it. We will add these things. And I can tell you almost every single case, every single project, you will need to do so many different changes. That's why it never hurt or it never a waste of time to build these interfaces in the beginning right away. All right. So you can go to find some of the good Java open source project. Okay, let's actually try it. So Java open source projects. Okay, I don't know what would be a good one. So top 50. All right, so let's take a look. And let's find some of the good, let's try Elasticsearch. So this one that is a searching library. If you want to implement some kind of a search feature to your software, you don't need to implement your own Google, right? So you can use Elasticsearch. This is the open source project you can use. Looks like this is done in Java. Okay, so let's find out their source code. Let's take a look. Source code, there obviously is a huge code base. Let me actually find where is the source. Okay, so these are all about the building. I don't know if this is the actual the code base. Okay, but let's try. I'm trying to find the info. This one is more about a build. This is not actual the source code. Let me find the actual source code. Maybe server. Yeah, this looks like more kind of a source. Go to search. Okay, see that's so many like different projects, folders. And then query. All right, so if you're trying to open any of this source code, okay, you will see, you can see extends, right? See other things, query search request, extends implements. This one here, all right, extends. All right, so that's one folder. So let me go back to some other folders. or let's just even the exception, or exception you have to do. Okay, that's nothing. But then this is their own like customized exception. Multi-value mode, implement writable. All right. So search service. This one probably is the interface. No, actually, extends implements. All right. So my point is, if you open all of the code base, you can find almost every class has either extend or implements. So that's really why I'm highlighting use inheritance as much as possible. Never tell me that I don't feel that this is the inheritance. I don't feel I need to change it. Okay, don't make that assumption. And one day you will change, and one day that inheritance will bring you the benefits. All right. So I highly recommend you guys take a look at the actual professional Java code. And you will see how different their code looks like. Just by looking at the code, you don't have to understand logic. It actually looks quite different from the ones you wrote. All right. Just look at how many kind of classes and the inheritance they're using. Okay. So that's kind of the point I have. It's really, if you're not doing the inheritance, you're not doing the OOP, you're not really using the real Java. Okay, another lesson you need to know is the switch statement. All right. So when I was in Amazon, some of the senior developer told me that you should not use switch statement at all. All right. So this is a very something that I never forgot. Even though switch is a valid statement in Java, you can do that, but it's just such a bad practice because any kind of a switch statement, that means you can build a hierarchy to replace it. So that's why you don't need to build a switch. The really downside about switch is when you use one switch, you might need to use another one. When you have a lot of switch statements, when you need to change the new type or remove an old type, and you have to change that everywhere. That's why this one is really bad. Just don't even use that from now on. Okay, switch statement is gone from your Java code. All right, if you use that one, it's just not very professional. Okay, any questions? So this one is really simple. Okay, all would prefer hierarchy. This is the yes or no question. Don't do tag class. Finally, all right, last for today. Do you prefer composition or inheritance? All right, so you all understand inheritance, that's about like your reuse. What about composition? All right, so I will show you an example. Composition means that you create a reference and then use that one. Now this is, I think, a very interesting principle and you should keep in mind. All right, so to illustrate this one, I need to show you a one concrete example. So I have this use case here. Okay, I want to use and build a new kind of a hash set. Okay, so let's kind of review what hash set is. All right, so I'm going to create a new package here. I'll do my own set. So set is one data structure provided by Java. So I will do a driver. Okay, the hash set I'm talking about is this. For example, I got a bunch of strings. All right, my set, and I'll implement right, something like this. So set basically means only keeps a unique number. So my set, I can add A and B and C. So I added 4 times, but when I print it, my set, it should only show ABC because the A are unique. All right, so that's how it works. And then you can also add a list of things, I think. For example, you can add all. And I think you can add, I don't know, maybe a string, right? So let me try if I can add a string. So if I can add a string array of string, something like this, A, D, E. Okay, so you need to do a list. So I will need to create a list. All right, so I'm gonna add all the things from the list. At the end, the result should be A, B, C, D, E, right? No matter how many A's you have, but it will keep just all the unique one. That's how the hash set works. So this one I already have, it's working, but I want to extend this hash set class. I want to add a little feature. I want to see how many elements has been added to the set. Even though right now inventory you only show me 5, but I want to know how many you added. You try to add. For example, here you added 4 times, and then here you add 3 times. So in inventory, I want to know you actually try to add 7 numbers, but because of the duplicated ones, I only saw 5. So right now this hash set doesn't give you that capability because it doesn't record it. So what I want to do, I want to extend it, right? So if you want to extend that feature, the most straightforward way is to, for example, build a inheritance. All right, so let's try that. So I'm going to build my own. I will call it CPP hash set. All right, so this is our own hash set. And I always don't want to write everything by myself. I will just extend hash set class from Java. All right, and I think I need to do this kind of a generic type. Okay, so hopefully I'm doing something right. And then that's it. So once I have it, all right, I can then do override some of the method. For example, one method I know I'm calling is something called add, right? So I will do this one here. I will try to override it, and I can just use Eclipse to help me to generate source and override implement method. I will do this thing called add. So it's actually coming from this one here. So I'm gonna add this one here. All right, so I'm trying to add some method, some element to my class, right? So once I do this, okay, so it automatically, well, again, I don't have to write anything. I just want to do something right before it returns because all the logic has been already implemented here. I don't need to redo it. But what I'm adding is I'm adding a counter, all right, to count how many times I have tried to add this one. So I'm gonna do a getter and a setter, but only probably getter. I don't want to do a setter here. I don't want people to change it. All right. However, right here, I can say counter. All right. That's it. And then I can just get a counter to know how many times I have tried to add this one. All right. Any questions about this one? I'm inheriting the hash set to extend this new feature that didn't exist. So let's try this one here. All right, so this time I am not going to use this one. All right, I'm going to use new CPP hash set. All right, so I'm using this one here and everything remains the same. All right, and then this is the final list, final set when I try to run it. Same result, didn't change anything because I literally didn't change anything about how the set works. It's still using everything from the parent. But now I can try to find out my set get a count. The reason I can't call this get counter is because I'm not really forcing the type, so it's called CPP hash set. All right, now I can get a counter. Let me run it. Okay, so it gave me 7. All right, so yeah, I think I need to explain a little bit more things. So let's not worry about I think there's something about the list here. Okay, I will comment it out. Let's still be simpler. Only because I'm only doing the add right now. So I'm gonna do this one, run it. So this one gave me 4. It's very easy to understand because this is a 1, 2, 3, 4. I tried 4 times, and then this one counter will be added 4 times so that I can get a counter. So that's 4. So that's exactly what I want. But there's a little special case here about add all. All right. So add all, actually, I didn't really do it yet. So what I should do is actually I do this one here, source, add all. Right here. Okay. So this is actually implementation. And obviously this is C is the collection you're sending. If I do here, I should do counter C dot size. Because if you're giving me 3 numbers and I'm gonna add that for 3, and that's how I got the count, right? So I keep doing this one here and let's test it. Now I'm bringing back my list. All right. And I run this code. And then you see this time the counter becomes 10. Right? So this is 1, 2, 3, 4, 4 times. I add 4. But now once I add this add all, which has 3 numbers, so it's supposed to give me a 7, but now it gave me a 10. What happens? All right. Since I showed you the 7 before, so some of you actually saw it, because previously it was a correct answer, but now when I actually overwriting this one, it caused this bug. Yeah, as a lot of you figured out that it's 3 plus 4 and plus another 3. That 3 come this from here. This one looks very straightforward because you are just adding the side, right? If you have 3 numbers, I'm going to count for 3, and then I assume that you're going to execute it. However, some of you did see that maybe this one also caused this one. That's why you got extras, right? And then let's see if we can prove that, okay? Let's see if we can find out the source code for this one from here. Okay, let me try. Yeah, you can. So this is actually the source code for Java for abstract collection class. Okay, there is one method here called add all. That's the one we're using. Okay, this is a source code from Oracle. All right, so where is add all? This one here. Now, if you look at this code, it's very easy to see that there is a for each loop to iterate all the elements. And if you're adding that one and somehow do this one, but you can see it's actually calling the other add method. All right, so this add all really doesn't really do all this add all together. It just use a loop that try to add everything one by one, which we'll call this one. That's why if you don't do this one, this is actually right result, right? Because when you go back here, you will see 7. But when you are adding this one, looks like a very reasonable change, but it turns out it's actually mess up the algorithm because it will get extra. Because you're adding it once here, and then it will add 3 more times right here. Because this method uses this method, right? So that is a problem about inheritance, about reusing the code. This is the same issue I mentioned earlier about the conflicts, because how many of you actually know the implementation of this one? It does use this one. Until today, I show you an example, nobody even thought about that one, right? And also it's impossible. You can't just go to look at every single code right before you reuse the class. And this one here has this many code, and then this parent, if you go more, and this one has more code, and there is one more level, I guess, abstract collection, so many more code. And after this, you got collection, interface, and developer cannot afford to read every single thing from the parent class. But for this kind of situation, and if you don't know it, and then you will create this kind of conflicts, right? So that is the potential issue about using inheritance or extending things with the inheritance. So the question why this one to use? Well, because this one is the same example as I mentioned earlier about the get unique ID. Since you are overriding things, okay, this one will need to call an add. By default, it will call the add from the hash set. But now since you're overriding it, it will call the add with this one here because you're at the same level. This is how the polymorphism works. If you don't have this one, then that's fine. It will not call this one. But once you have this one, you override that method. It will be calling this one. The super means it's calling the super add all method, but it doesn't mean it calls super add. Okay, so that's something that you need to be careful. Once you override it, and then this level just always going to use that override version. So that's one way you solve this problem. Now there's another way. All right, so if I use something called composition, let's see how that works. So I'm going to do a CPP hash set 2. All right, so I create another class. All right, so and in order to make it like a type, make it same as a hash set, I will do implements. I call it set. Okay, set is the interface. Okay, I want to do the same thing for to implement everything I have for hash set, but this time I'm going to do a composition which uses interface. So if I do this way, I do have to implement everything from here. But I don't want to do this by myself. I'm going to use something called composition. Composition means that I'm just going to create something here internally. All right, my set, and I will implement it like this. Then for every of this call, I would just delegate to it. So I would call my set size. Did you get it? This one called my set dot is empty. This one called my set dot contains. Right? So I'm not gonna write every single thing, but I'm gonna do the most important one, like add. I'm gonna call it my set dot add. And then there's add all. My set dot add all. All right, do you get it? So this is called composition. Composition means that you create a reference and then you call those reference directly in your call. Now, once you have this one, you will not have that kind of risk because you're not doing any of the inheritance reusing the code. There is no conflict. So I can just safely create a counter and I will create a getter and setter. And then this time you can just do that logic without worrying about that one. So counter purpose. And then this one here is counter at c.size. All right. This time you don't need to worry about it because this time you call this one, it actually goes to that object. That one has nothing to do with this one here. Okay, be careful. These are totally different situation right now. This one, you delegate it to the internal object. You're not going to do anything with this one. This is just kind of a new method you implemented under this interface. So I come back to my driver right here. And if this time I change it again, new CPP hash set 2, as you can see, it still falls into this interface. I can still do that. But this time it's not going to create an issue for me. So I'm going to run this code. This gave me a nice 7. All right. The reason is when I do composition, you're not creating these potential conflicts. They're all separate. They are all delegated to that original method. You're only adding your behavior on top of it. Okay, that's the major difference. Okay, so I put this example here, and also I will upload the video. So I want everyone to really look at this carefully. All right, so I try to run through this really quickly to give you the core idea, but then it's really good that you go ahead and try the same thing on your own so that you can have a better understanding. But to summarize this example here, inheritance is very easy as you saw. You just override 2 methods that, okay, very clean code, very quick, but it violates encapsulation because it forces the developer to know more details. Otherwise, it might break things and it might not work. All right, so that's the same example I gave you. If you do this way, you are going to create that conflicts. All right, but then if you forward, if you delegate, then it's different, and you will not have those kind of conflicts, because this method you're implementing are just for this interface, have nothing to do with that set internal, and this is a preferred way to go. All right, so the conclusion here is composition is actually better than inheritance when you're trying to reuse something. In other words, if you can create an object, just call some of the method to use that one, don't bother to do the inheritance. As you can see today, this some of the rules are all really falls into the same point. Inheritance is nice, it gave you reuse, but use that with cautions, because it may give you conflicts, it may give you too much things, it may expose a lot of information that cause extra trouble. All right, so just more thing to know about inheritance, even though I tell you that the inheritance is important, use inheritance, but still make sure you know the risks inside. All right, so that's the 6 rules I want to give you. A little bit more higher level, applies to not only Java but also a lot of other languages, but the idea is the same. All right, any questions? So the assignment, really simple. I just want you to do a simulation of this live polling tool. All right, so remember we use a Kahoot, we use Mentimeter. Basically, I give you a question and then people submit the answer. Eventually, I can see how many of you actually choose what answer. However, we're not asking you to do anything about server, okay? No server, and you don't need to do UI, nothing, okay? Really simple one, just a command line Java program, which you already know from day one. Again, you don't have to build a UI for this one. Not a desktop UI, not a web UI. You obviously don't need to do anything about the live submission database, no, okay? Just a standalone program to simulate that whole process. So that's the big concept about this assignment. And some of the functions you really need to implement. Number one, you should be able to create different kind of question types and then the answers, options. And right now I wrote 2 types questions. One is a multiple choices, one is single choice. Multiple choice means that you can choose multiple answers. A single choice means you can only choose one answer for your answer. Okay, there are 2 different types. As you can see, when you have different types, you probably need to think about some kind of hierarchy. And you can really specify any kind of answers, just a string, doesn't matter. And then you need to allow students to submit the answer. Every student have an ID, and every student can submit something to that question, to the service. The service is really the core part of the code that you configure some question, a given question, and some of the answers. And then you should start accept the submissions. All right, and the student can submit the answers. The voting service obviously need to track all the submissions and eventually be able to display that. At the same time, you don't want people to resubmit it, right? So every student can only submit it once. If you submit a second time, then it's going to override the previous answer. Think about what kind of data structure you use for this kind of a statistic part, the counting part. And then finally, you need to output the result, okay? How many of you choose A? How many choose B? How many of you choose this answer, that answer? Depend on the submission. And then when you run your code, you run this simulation driver. Okay, it's a main method. And then basically you can write some code to create a question type, create an answers, create a service. And then for the submission part, hopefully you can do some kind of random generation. Okay, generate a bunch of students and then random generate answers so that you can see the result printed in the console. All right. So these are the things you should actually implement. That's the only function we want you to implement. If you want to do more, totally fine. Okay, don't even need to ask me. You always feel free to add more features. These are just core requirements we have. And then we want you to write this in Java. And then the main thing we want you to do is to apply so far all this principle we told you. Inheritance, private, public, all just basically the 2 or 3 lecture we mentioned so far. All right, and we want to see if you are actually applying some of this OOP principles. We want to see if you're using actual the inheritance, and if you're using interface, if you're doing a lot of private. We want to capture all these good things about OOP. The goal is to change the way you write your code. Hopefully one day when we open your code actually look more like this, okay, not like a typical college student Java code, right? So really pay attention to see how their code looks like, and your code should be similar. So these are the core concepts you should implement, but it doesn't mean that you only have 4 classes, okay? You should have more than this, but just to highlight some of the core things you have. Yeah, so you create other classes, subclasses, interface, depending on your need, and this is your main method to run. And yeah, so it's very open. We just want to give you this kind of concept. You say you can write some code, but we're particularly talking about the principles. All right. Any questions?
So we don't need any command line input from the user, right? It's just going to be a self-contained program that runs.
Yeah.
And
Don't do
generates
command line because we can't really test it. It's too much trouble. Just do a loop and randomly generate a bunch of answers and print more console output, and so that we can see the result.
Okay, thank you.
All right. All right. Any other questions? All right, very cool. Well, if not, just I'll give you 2 weeks, okay? But shouldn't take too much time. Oh, by the way, you need to push this one to GitHub. Just send us I have a Google form here. Just put the link to your GitHub repository, okay? So that will be the easiest way to check. Yeah, Aaron, if you want to chat right now, it will be the best time to chat. If you need a different time, let me know. I can figure out a different time.